Alright, 9.5 is dealing with adding and subtracting these rational functions. So previously we've looked at simplifying them and breaking them down and multiplying and dividing them. So now we're going to be looking at adding and subtracting, which is kind of weird that we're doing adding and subtracting, which is usually what you learn first. If you remember back, you probably did in kindergarten or maybe first grade or maybe second grade. You learned how to add and subtract, and then like second, third, you learned how to multiply. So multiplication and division was usually second. For rational functions, it's actually easier to multiply and divide than it is to add and subtract. So that's why we're doing this one second. Okay, it's a couple extra steps, I guess, and it is a little complicated. So hopefully we can step through this. So whenever you're adding and subtracting rational functions, so again polynomials that are being divided by each other, what you're going to want to do is you want to find something called the least common multiple. And the least common multiple is the number that if you were to keep multiplying these numbers by, or the two numbers by something, what's the smallest number that can occur? What's the smallest multiple of them? So like 6 and 8. What is the least common multiple of those? Well, 6 goes 6, 12, 18, 24, 30, blah, 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 blah. If you look at 8, it goes 8, 16, 24. So since they both have a 24 and that's the smallest one, that would be considered the least common multiple of both these numbers. Okay, so that's what's, if you ever see LCM, least common multiple. Okay. So now we can also do a least common multiple with two polynomials. So we've got a polynomial here, 3x squared minus 9x minus 30, and we have another one, 6x plus 30. And so if we want to find what the least common multiple is, what we're going to do is that we're going to factor both of these. So if we factor the first one, if we look at this one, what can we take out of every single one of these in the first one? We can take a 3 out. And when we have a 3, we're left with x squared minus 3x minus 10. This can be factored down into x minus 5, x plus 2, and then a 3. Okay, that is the factors of this. Now, if we look over here, what can we factor out of both of these? We have 6, parenthesis, x plus 5. Okay, x plus 5. Right. And so those are our factors of all these. Now, when you are looking for the least common multiple of two polynomials, what you're going to be doing is you're going to see if there's any repeats. And in this case, the only real repeat here is the 3. If there is no repeats, what you're going to do is that you're just going to list every single possible one out there. So in this case, our least common multiple would be 6, which 3 and 6, the least common multiple of the two numbers is 6, so that's why it goes here. And then we just put all the other parts. Okay. We put all the other parts. Okay. Now, if any of them repeated, we would only put them once, and we'll see an example of that. But the least common multiple of those two polynomials is if we were to multiply all these together. And what we're going to want to do is we're going to want to keep these separate. We don't want to multiply them together. So looking at here when we're adding, first thing we have to do is we have to get a common denominator. Okay, a common denominator. And to do that, we need our least common multiple in our denominator. So we're going to factor the two bottom parts. The bottom of the first one could factor down into x minus 6, x plus 2. And then the denominator of the second one, we can take a 4 out, giving us an x plus 2. Okay. So when we do that, what we have now is that we want to find, okay, what is our least common multiple? Okay, x minus 6. Is there an x minus 6 over here in this one? No. So that means that's going to be one of them. X plus 2. Is there another x plus 2 over here? Yes, there is. So that's going to be one of them, and then we're going to get rid of that one. We're just going to erase the second one. And then 4, is there a 4 in the other one? No, so that gets dropped down as well. So our least common multiple would be 4 times x minus 6 times x plus 2. So as you see here, we only put that x plus 2 only once, okay, because it occurred in the second part. Now, with this least common multiple, what we're going to do is we're going to multiply both of these by the parts that are missing in our least common multiple. So as you see here, this is still the same problem. Okay, the big fractions in the parentheses is what we originally had. Now if you look at this first one, we have x minus 6x plus 2. What was missing in our least common multiple? It was the 4. So we're going to multiply the top by 4. Now if we look at the next half, what was missing? X plus 2 and times 4. What was missing? The x minus 6. So we're going to multiply the top part by x minus 6. So 4 times 1 is 4. X minus 6 times 3x would be 3x squared minus 18x. Okay. And then our bottom, and then once we distribute this, we add it all together. We combine like terms. So in this case, we don't really combine anything, but we put it all under one big fraction. And then our least common multiple goes into the denominator. Okay. So again, this is a lot of moving parts. What is this? Okay. Now, when you subtract, you do the same thing, except you just got to remember to do the subtraction. So let's factor the bottom. What can we factor the bottom to? Well, we can take a 3 out, leaving us with x squared minus 3x plus 2. X squared minus 3x plus 2 can factor down to x minus 2, x minus 1. So we have 3x minus 2, x minus 1. Now if we look at the next half, we can take a 3 out, give us an x squared plus x minus 2. That can be broken down to x plus 2, x minus 1 with a 3. Okay. Now, what is our least common multiple in these? Well, our least common multiple would be 3. That's what's the same in both. Okay, let's do a different color. So 3 is the same in both. Then we have x minus 2. Is there an x minus 2 over here? No. So then we have x minus 1. That's the same in both. And then we write everything else that's left. So x plus 2. Okay. So there is our least common multiple. As you see, it's a lot. And then what we would do is that we would multiply this first part by what's missing. So the part that's missing in this first part looks like it's going to be x plus 2. X plus 2. And the second part, we're going to multiply by what's missing, which is x minus 2. And then we would distribute into the top, and then we would combine the like terms. And then our least common multiple ends up in our denominator. Okay. So again, you would distribute this x to both parts, FOIL these two together, and then subtract them. All right, complex functions. Complex functions are fractions within fractions. And so what we have to do here is that we have to get a common denominator in the numerator and then a common denominator in the denominator. Okay, so we have to do it for both parts. So we're just going to focus on the top part right now. 1 over x plus 3 over 1. Okay, what's the common denominator? Or the least common multiple? It's x. So we're going to multiply the second one by x. That gives us a 1 plus 3x all over x. Now we look at the next part. So that was this one. Now we look over here. We have 1 over y plus 4 over 1. Multiply the second one by y, giving us 1 plus 4y all over y. Oh, that's kind of a 4. Now, since we are dividing, if we divide fractions, we flip and multiply. So we're going to have 1 plus 3x all over x multiplied by y over 1 plus 4y. Okay. And then all we're going to do is we're going to multiply it across and distribute to each part. And that ends up getting us our answer of y plus 3xy all over x plus 4xy. Okay. And that's about as far as we can go on that one. Okay. So again, get a common denominator and then flip and multiply. Your IRAT, first one, add it together. So again, factor the bottoms, find your least common multiple, and then multiply each one by what it's missing, and then add them together. And then you have a complex fraction on the bottom, so get a common denominator in the numerator, a common denominator in the denominator, and then flip